In this video, I want to discuss properties of quadrilaterals. Quadrilaterals are any four-sided shapes. I've got four examples over here: parallelogram, rectangle, square, kite. The two quadrilaterals that I'm not going to discuss in this video are trapeziums and rhombuses. I want to start off by only discussing the lengths, the sides of these four shapes over here. Right, start off with the parallelogram. It says opposite sides are parallel and of equal length. So for example here, this side over here is opposite this side over here. They're opposite one another. So the opposite, the parallel, meaning what? These two sides are running like train tracks. So for example, if you've got two lines like that, they're parallel to one another. They're running like train tracks. Same here, parallel. Just like the sides of a book, opposite sides of a book, opposite sides of a page, opposite sides of a wall, they're supposed to be parallel, right? What is not parallel? Something like that. These are not parallel. So we've got the two sides, opposite sides that are parallel and of equal length. So this side is the same size as this side, right? There is another pair of opposite sides that are parallel and of equal length. It's this over here. So this side over here is parallel to this side over here. They're opposite one another, they're parallel and of equal length. So this side over here corresponds with this side over here, right? They're of equal length. Right, moving on to the rectangle. Opposite sides, again, opposite sides are parallel and of equal length. It's the same description as what we did for parallelogram. So it's the same description. So this, remember, this side corresponds with this and this side corresponds with that. Okay? And that fulfills this sentence over here. Opposite sides are parallel and of equal length. Right, moving on to the square. All sides are of equal length. So this side is the same size as this, same size as this, same size as this. That's what makes this a square. All sides are of equal length. Moving on to the kite, a pair of adjacent sides are of equal length. Adjacent means next to each other. So you got this side corresponding with this side over here. They are adjacent to one another, next to each other, and of equal length. There is another one like that, right? This side over here corresponds with this side over here. They're adjacent to one another, next to each other, and of equal length. Right, that fulfills that. Right, now I want to talk about the angles. Opposite angles, so back to the parallelogram, opposite angles are equal. This angle is opposite this angle. They're the same size. Right, there is another pair like that. This one is opposite this and of equal size. Right, for the rectangle, all interior angles are 90 degrees. Interior means inside the shape. All interior angles are 90 degrees. So this one is not right angle, right angle, right angle, right angle, 90 degrees. Just like corners of a page, book, wall, right? Same for the square, all interior angles are 90 degrees. Right, for a kite, only one pair of opposite angles are equal. This is opposite this and they're equal to one another, same size. But this over here is a lot wider. That angle there is a lot wider, it's bigger than this one here. It seems a bit narrower, right? They're not, even though they're opposite, they're not equal size. So these two angles don't count. Only one pair of opposite angles are equal. Right, I want to move on to now to discuss diagonals. What are diagonals? Diagonals of a shape, quadrilateral, are these when you connect one corner to another corner like that. There. These are diagonals. Got two diagonals there, are of equal length. So for a parallelogram, they're of equal length and bisect each other. That means cut in half. So for example, if I've got a line over here, that's the middle. And then if I take this line over here, I'll do this in a different color. So this green line over here cuts the blue line in half. So we describe it like this: the green line bisects the blue line, i.e. green line cuts the blue line in half because the green line goes to the middle of the blue line. But if I was to twist this sentence, let's say if I was to say, well, I couldn't say now, could I, that the blue line cuts the green line in half. Right, let me just exaggerate this. Now, does the blue line cut the green line in half? No. The middle of the green line is somewhere here. So that blue line does not bisect the green line. Whereas the other way around, if I was to say it the other way around, the green line does cut the blue line in half because the green line goes to the middle of the blue line. Right, in this situation here, look, if I've got this situation here, both these lines cut each other in half, right? They bisect each other, right? Same with this as well. Right? These two lines bisect each other. Same for, it's exactly the same for the rectangle. Diagonals are equal length and bisect each other. Same description as for a parallelogram. Exactly the same description. Right, for a square, diagonals are of equal length. Let's draw in the diagonals. Diagonals of equal length, okay, they are the same size. They do bisect each other, they cut each other in half. But there's a key word here, there's an extra key word here, perpendicular. Perpendicular means 90 degrees. Right, so for example with these, that's 90 degrees, 90 degrees, 90 degrees, 90 degrees. So these two lines are perpendicular to each other. Similar here, this line over here is perpendicular to this one here. So diagonals are of equal length. As I can see, they're the same size. They are perpendicular bisect of each other. They cut each other in half, but they also happen to be 90 degrees, 90 degrees, 90 degrees. Right, for the kite now, the diagonals are perpendicular to each other. So the diagonals are perpendicular to each other, meaning this is 90 degrees, 90 degrees, 90, 90. Right, for the last sentence, only one diagonal is bisect of the other diagonal. I'm talking about this situation over here, this one over here. Remember, it's the green line that bisects the blue line, not the other way around. The blue line does not cut the green line in half, so you can't say the blue line is the bisect of the green line. If I apply that here, only one diagonal, which one is that? It's this one here. This one over here, this green one over here, cuts the blue line in half. It goes to the middle of the blue line. So it's the green line that's the bisector of the blue line, not the other way around. The blue line does not cut the green line in half. That's roughly the middle. See this point over here? That's roughly the middle of the green line. That blue line does not go through that point to the middle of the green line. All right? So only one diagonal is bisect of the other diagonal. There you go. Right, these are the properties of these quadrilaterals. The two shapes, the two quadrilaterals that I did not discuss are the trapezium. A trapezium is like a triangle with the top chopped off. So that's a trapezium. You could have it like this as well if you want, on its side. You could have this side chopped off. So that's a trapezium, right? I'm not discussing the properties of trapezium in this video, and the one that I'm not discussing is a rhombus. Right? A rhombus looks something like this, where all four sides are the same, right? Like a square, but these are not 90 degrees.